Bonjour, je m'appelle Miss Townsend et j'adore math. Welcome to Math with Townsend. This video is for grade 9 academic students who are studying measurement and geometry. This is part 2 of that unit where we're looking at three-dimensional measurement. In fact, this is video number 4 of the three-dimensional measurement portion. In video number 1, we looked at the volume formula, and in video number 2, we did some volume questions together. The last video, number 3, was where we explored the surface area formula and where they came from. And so now we're going to do some surface area questions together. So let's go ahead and do that. The first question says, examine the tent below. What is the surface area of the tent, including the ends and the floor? So we know we have a surface area question. We know that this shape is clearly a triangular prism. So with that in mind, I'm going to ask you to press pause on the video. Try the math on your own, and I'll see you on the flip side. So this is a triangular prism, and all 5 sides of the prism are going to be counted for. So again, the 5 sides, there are 3 rectangles and 2 triangles that make up the net of a triangular prism. So if we look at the formula sheet for a second, and here's the formula sheet for triangular prism, it tells me that the total area, so the total surface area is add the rectangles together, and then there's 2 triangles. So you could simply just label all the pieces with A, B, C, L, and H, and then use this formula. But I'm not really a big fan of formulas. I prefer kind of thinking about things. So let's think about things together. First of all, we know that we have 2 triangles, and the area of a triangle is 1/2 base times L, and we have to call it L. So there's L, and here's the base. So the area of one triangle is going to be 1/2 times 1.5 times 1.5. So typing that into my calculator, I get that each triangle is 1.125 meters square. And we know that there's going to be 2 of them eventually. So now let's start looking at the other parts of this tent. So let's shade this side in green, and we'll call it side number 1. So side number 1 is a rectangle, and you can see that the dimensions are going to be 2.5 times 1.7. So 2.5 times 1.7 for that side is going to give us an area of 4.25 meters squared. Now, there is a side that we can't see at all kind of back here. So imagine for a minute that you can see transparently that there's a side back here. What are the dimensions of that side? Well, we know that this is going to be 2.5 because the tent goes back in that direction. And without any other information, we would have to use 1.7 as the side length over here. So in fact, this second rectangle is going to be identical to the green rectangle that we've already discussed. And the third side of the tent is going to be the bottom rectangle. So the rectangle part that's sitting on the floor is the third part of the tent. And you can see the dimensions of this are 1.5 times 2.5. So that's 1.5 times 2.5. So the third rectangle has a total area of 3.75 meters squared. So adding up all 5 sides, I would get a total surface area of, so I need 2 of the triangles plus the green side, the red side, and the bottom side. Oops, 7, 5. So adding this all up and rounding correctly, and when I'm all done to 1 decimal place, gives us an answer of 14.5 square meters. And of course, if you had simply labeled A, B, C, B, and L and used the formula blindly, you would have got the same answer. I just prefer to do my own thinking when it's possible. Next question. It says the figure shows a greenhouse roof in the shape of half a cylinder. What is the approximate surface area of the curved roof? So before I let you ask you to press pause, we have to make a decision as to whether or not this area here and the corresponding area that we can't see at the back, do we consider this to be part of the roof? My vote is no. This is supposed to be a greenhouse. Um, so you can imagine that there would be a little door here where you could walk in and water your plants. So I don't consider this or the other part to be part of the roof. So I only want what's called the lateral side in your calculations. Okay, so would you please press pause in the video, try the math on your own, and I'll meet you on the flip side. Okay, so it is a surface area question, and the shape in question is obviously a cylinder, but make sure that you don't, again, blindly look at the formula sheet. Here's the formula sheet. But again, we're not counting any of the circular portions as part of the roof. So the only part of this formula I need is the lateral surface. So I'm just going to take 2 pi RH because I don't want to include the circular part. So I need the surface area of the lateral surface of a half a cylinder, right? That's the formula I need. So here's the lateral surface, and here's half of it. So 2 pi RH is the lateral surface, and I only need half of it because clearly this is only half a circle. This 2 cancels out this 2 quite nicely, so I don't need to go through the math where I multiply by 2 and then divide by 2. That's a waste of time. So I just have pi RH. So pi, the radius would be half of 6, and then h is the long distance 30. And in my calculator, I get 282.6 meters squared. Pretty straightforward question if you think about it. Next one. Ooh, a good one. If the radius of a sphere is tripled, by what factor will the surface area increase? So I'm going to help set this up before I tell you to pause. So I have a sphere, and this sphere has a radius called r. And it also has some surface area. Again, I don't know what they are because I don't know r, but I have a sphere with radius r and some surface area. Now I'm going to triple the radius, so obviously a bigger sphere. So I'm going to say that instead of r, we're going to call the radius 3r. And the question is, what happens to the surface area? Okay, so with that little bit of heads up, I want you to pause the video and see if you can figure out the factor of increase for the surface area. Okay, so press pause, do the math, and I'll see you on the flip side. So here's what I did. I said that for R, for plain old R, the surface area is equal to, and again, you can use the formula sheet, 4 pi r squared. That's the surface area of a sphere. Oops, let me make that neat. This is an important question. So the surface area, if I have r, is 4 pi r squared. Now, if instead of r, I have 3r, look what happens to the surface area. I have 4 pi, and instead of r squared, I have 3r squared. So those of you who said that the surface area is 3 times bigger should already be seeing your mistake, because the radius is 3r and the radius gets squared, so this actually becomes 9r. And so look what I have, 4 times pi times 9 times r. Now compare that to what I had originally. Oops, times r squared, my bad. Now, really the only difference between what I have here and what I have here is this multiply by 9. Because the original surface area was 4 pi r squared. The new surface area is 9 times 4 pi r squared. And that should make sense to you, because if I triple the radius and the radius gets squared, So if I triple and then square, so here's x, I'm going to triple it and then square, well, we know that 3 squared is 9. So it's 9 times the original surface area. So by what factor will the surface area increase? By a factor of 9, meaning it's 9 times bigger. Okay, let's look at the next question. The cylinder pictured below has a surface area of 660 square centimeters. We're told only that the diameter is 14 centimeters, and it says to find the height. So I'm not going to give you any other information than what's in the question. What I want you to do is to press pause on the video, do the math, and I'll see you on the flip side. So this is a surface area question involving a cylinder. And the cylinder appears to be intact. So I'm going to use the entire formula, which looks like this. Surface area of a cylinder is 2 pi r squared plus 2 pi r h. So what do I know that I can substitute in? Well, I know that the surface area is 660. And I know that the radius is half of 14. So the radius is 7. And of course, the thing I'm looking for is h. So substitute in 660, 2 pi 7, 2 pi. So really, the only thing I don't know is the h. Everything else has a numeric value. So substituting in, I get surface area 660 equals 2 times pi times radius squared plus 2 times pi times radius. And again, there's my unknown h. So what I have is an equation with only one unknown value, h. And all I have to do is solve or isolate for h. So I'm going to do the math here. I'm going to multiply these together. And I'm going to do the math here, multiply those together. So in my calculator, I get 2 times pi times 7 squared is 307.72. 2 times pi times 7 is 43.96. And don't forget, this is still multiplied by h. So at this point here, again, it should be automatic for you to isolate or solve for h. So we're going to subtract 307.72 from both sides. So I'm left with 43.96 times h. So to get rid of that, I obviously need to divide by 43.96. So that division in my calculator gives me a value of 8.0 centimeters for the height. So a pretty straightforward question. You just have to be careful with your solving and algebra. So last question, here it is. A tent has the shape of a cone. The radius of the base is 3 and the slant height is 5. What is the approximate surface area of the tent, including the floor? So at this point, I want you to press pause on the video, try the math on your own, and I'll meet you on the flip side. So a fairly straightforward question. Here is the formula for the surface area of a cone, pi rs plus pi r squared. And s again means this slant height. So it's not as exciting a question as I'd hoped, because what I was hoping is maybe they would tell you the height, and then you'd have to use the Pythagorean theorem to find the slant height. Wouldn't that be exciting, kids? Yes. So bear in mind that that's something you could see in the future. However, this one's much more straightforward. They gave us absolutely everything we need. So this is just a question of substitution, calculator, and we're done. 75.52. So that finishes our discussion of surface area. Obviously, there's a lot more questions out there, but that's enough to kind of give you a really good feel for how to deal with surface area. So we're also done the 3D measurement part of this particular unit. The final part of this unit is optimization. So make sure you look for that video because you can't ignore that portion of this unit. So I'll see you there.